Okay. Hey, everybody. Can you hear me all right? Okay. It's great to see you all here on this beautiful, foggy Friday morning at Droidcon San Francisco. Thanks so much for coming out. And my name is Chuck Greb, and I'm the mobile lead at MapZen. And today we're going to talk about Android. But not just the Android with a capital A or a capital G, as it seems like sometimes, but we're going to talk about all the Androids that exist in the world. And more importantly, we're going to talk about how we, as application developers, can build apps that will work on a variety of different versions of the platform and reach the most users possible. So MapZen, where I work, MapZen is an open source mapping lab. So what does that actually mean? Well, we build open source tools for mapping and location-based apps that also we coordinate and partner with other organizations and governments and nonprofits and companies on open geodata initiatives. So to get more mapping data into the public and then tools so that developers can take advantage of that. And so I want to start out today with just taking a little quick look at kind of some globally relevant statistics for the Android market and really the smartphone market as a whole. So in this first graphic, what we're looking at is this is a report for over all of 2014 that came out about a year ago of smartphone sales worldwide based on operating system. And so what you can see here is that Android is the clear leader when we're looking at things from a global perspective. You know, in the United States, we often think that Android and iOS are kind of neck and neck, but when we're looking at this from a worldwide perspective, Android is clearly the dominant smartphone platform with over 1 billion devices, with a B, shipped in 2014 alone, and occupying about 80% of the global market share. And then you have iOS following that up at about 15%, and then you have some other guys down below that I may not expect to see on the stats for 2015 when they come out. Now, let's take a look at this next chart, and this is similar data to what we had on the first one, but what is interesting about this is in this particular report, so now we're just looking at the second quarter of 2014, but the interesting thing here is that the data is being reported with two separate categories for Android. So on one hand, you have the Android Open Handset Alliance. So what is this? This is like the greater Google ecosystem. These are all the versions of Android running on devices that participate in the Google environment. Contrast that with AOSP, which here is meant to signify versions of Android that are running that are not compatible with the Google ecosystem. And so we can see that we have about 30% of devices that were shipped in the second quarter of 2014 were actually running a non-Google version of Android. So here's one more slide I have for you with statistics on it, and this is looking, so now we're moving ahead in time. This is looking at quarter over quarter for the third quarter and the fourth quarter of 2014. And there's a few interesting insights we can glean from this slide. The first one being that, so forked versions of Android, or AOSP as they're calling it here, has actually continued to grow to where by the fourth quarter of 2014, it's now up to over 40% of new devices getting shipped are running a non-Google version of Android. Another interesting thing here that we can look at is that actually for all the time that ABI has been tracking this smartphone global market data, this is the first time you saw a quarter over quarter decline in the number of Android devices shipped. And you can see that decline is happening more on the Google side than it is on the forked side. So what does that tell us? Okay, forks are relevant. And then one last note about this international market is that if we look at where these devices are being sold, it's primarily in India and China. And so these are the markets where you're primarily seeing non-Google versions of Android growing in popularity. And so as a developer building an application, if you want to reach the widest possible audience, somebody told me there's a whole lot of people in India and China. And so you want to be able to tap into those markets, but in order to do so, your device or your application needs to be able to run on devices that don't necessarily support the Google ecosystem. Okay, so next, we're going to talk a little bit about the Android open source project and what that kind of means in its totality. So for me, personally, AOSP is one of the reasons that I got into Android in the first place. So I came from a strong open source background and kind of believe in the greater community and the common good, and having, the best innovation comes when you open it up and let different ideas come from different directions and see what happens, right? And so that's the reason I chose to get into Android over iOS, for example, is because I was excited about that and being able to crack open the code and see what's happening under the hood. And so for me, that's one of the primary draws of the Android as a platform. And so here's just a quick overview, and this comes from the AOSP documentation of what exactly is contained inside of AOSP. So you have at the top your application framework. Below that you have some binders for inter-process communication. Below that you have the Android system services, including things like media. And then down below that you have your hardware abstraction layer, and then running at the very bottom beneath all of that is the Linux kernel. And so as a developer, all of this is available to you. You can check out the code, you can build it on your local machine, you can change it around, and you can produce your own version of Android. So the thing is, if we can do that as individual developers, so can other companies. And in fact, a lot of them have. So that brings us to Android forks. And so as we start talking about Android forks, well, let's make sure we're all on the same page here as exactly what do we mean by a fork. Well, the good thing is we have Fox News to help us out here. So using the GitHub dictionary that they've provided us with, if you look down there at the second item, you can see that forked is simply the code for the term for code editing. So I think that about clears it up. We'll wrap it up here. I'll take questions outside. Thank you very much. No, but actually, well, before I move on, actually my favorite part about this slide is their indiscriminate use of both double quotes and single quotes in the different definitions, which to me says they must be big fans of JavaScript. Okay, so what exactly is a fork when we're talking about it in the Android context? Well, it's some modified operating system that is based on the Android open source project. Now, you might ask, well, what's the difference between a skin and a fork? So when we're talking about things like TouchWiz or HTC Sense or MotoBlur, people often call these skins of Android, and technically they are forks. They're a modified version of the operating system. But really, when we're talking about a fork, normally we're talking about some greater degree of customization, not just a change in the appearance, but in the actual functionality of how it works. And so here's an important point, and that is, depending on how much you deviate from the main line of Android, your version of Android may or may not be compatible with Google Mobile Services. So what is Google Mobile Services? Well, that's kind of the umbrella term for Google's version of Android, which includes things like the Play Store, or the Google suite of apps like Gmail, Calendar, Drive, Maps. It also includes this other piece that we're going to talk about later called Google Play Services, which I'm sure a lot of you are already familiar with. And as we can see, there are a lot of forks of Android out there. So what I'd like to do in the next section is actually just go through some of the individual forks that I think are most relevant and most interesting right now. Did everybody get their picture? All right, so the first one I want to talk about is Cyanogenmod. So Cyanogen started out as a very popular fork of AOSP early on as a community-driven project that really allowed you to have a very highly customized and optimized version of Android running on your device. Well, what started out as a community effort eventually grew into a company, and so now you have the company Cyanogen backing Cyanogenmod. And Cyanogen does, they make no bones about what their aspirations are. Actually, a year ago, the CEO of Cyanogen stood on a stage here in San Francisco and said, we're going to take Android away from Google. Rather bold claim, right? But at least they're not mincing words, and we know what their goals are. But it's still a very interesting and relevant version of Android that a lot of people choose to run on their devices. And when you install Cyanogen, the actual suite of Google services is optional. So you can either opt in to the Google ecosystem or you can opt out. The next one I want to talk about is Amazon's version of Android. Wow, that's great. Can you still hear me okay? All right. So Amazon's FireOS is one of the first popular forks of Android that was not at all compatible with Google mobile services. And so this is what runs on the Kindle Fire tablet devices, and then also the Fire phone, which was kind of a flop. But still worth paying attention to because it was one of the early adopters of a non-Google version of Android, and I believe the tablets are still relatively popular. So given that they don't opt into the Google environment, they also have their own app store, the Amazon App Store, where you can distribute your apps. So the next one I want to talk about is MIUI, or MIUI, or I'm not exactly sure the correct pronunciation. Actually, there's a pretty long thread about it on XDA developers about how you actually say this. But I'm going to go with MIUI, but it's from Xiaomi, the company. It's based out of China, and it is the most popular smartphone platform in China. So the interesting thing about China is Google services are not available there. I'm not just talking about on Android, but there's no Google services, at least not in an official capacity. And so the Xiaomi version of Android does not support the Google environment, and so you have most Android users in China with no access to Google. And so given that, they use the Mi App Store, which is actually available outside of China as well. And now they're also currently working on an international version of MIUI to be distributed on devices outside of China, which hasn't really quite caught on yet. But that one will support the Google ecosystem. So they kind of have these two parallel versions in development, one for inside China and one for outside. Another one I think worth mentioning right now is Oxygen OS. So for those of you who are familiar with OnePlus, the OnePlus One originally shipped with Cyanogenmod on it, but then OnePlus and Cyanogen had kind of a messy breakup over distribution rights in India. And so they wound up dropping, I mean, maybe Oxygen was their plan all along from the beginning, but they wound up dropping it in favor of their own homegrown fork called Oxygen. They dropped Cyanogen for Oxygen, sorry, I got that mixed up, which is now what ships on the OnePlus 2. And so at this time, it's still very similar to your vanilla Nexus Android experience, but it'll be interesting to see where they take it. So here's another one that I think is worth looking at, and this is a version of Android coming from Silent Circle. And so they're most popularly known for their suite of security and privacy software. And so what they did is they built their own fork of Android with exactly that in mind, security and privacy for the user. And so with theirs, it's focused around, actually two of the big selling points are encrypted data on the device, as well as encrypted communication using their own phone and SMS applications, as well as some other features that give you control over your data, like spaces. They kind of run like virtual phones on there, so you can have multiple users, or like a separate space for work and for personal data that can never intersect. And then they also have their own store. It's called the Silent Store. Last time I checked, I think there was about, I don't know, maybe 10 or 15 apps in there. So really not a fully featured, fully vibrant ecosystem, which kind of explains why the Black Phone 1, which did not support Google, never really caught on. The Black Phone 2, however, they actually have a partnership now with the Android for Work program, kind of Google's enterprise version of Android, which gives you a little bit more control over data and settings. And so you actually do get access to the Google suite of apps on the Black Phone 2 through the Android for Work integration. So definitely another interesting one to keep an eye on. Which then brings us to Nextbit, which recently released their first device, the Robin. And so their take on Android is they have actually modified it so that it's integrated with cloud storage at the OS level. And so it's almost like, you know, the selling point is you have a phone with unlimited storage on it. They have some smart algorithms to back up the apps and the data that you use less frequently, offloaded onto the cloud, and then it frequently syncs back and forth. And then so the idea is whatever you need is going to be at your fingertips, and then whatever you don't use as frequently is backed up to free up that additional space on your device. Now, right at this time, it's really primarily like an integration with their launcher as far as backing up the actual applications. But when this could get really interesting is if they actually like open up an SDK to app developers where you can then, as a third-party developer, interact with that cloud storage. I don't know if that's the direction that it's headed, but I kind of hope so, because then that's when it might be really cool to see what people wind up doing with that. One other one I want to mention here quickly is Sailfish Os. This is kind of a derivative of the Nokia MeeGo project. So after Microsoft acquired them and killed that off in favor of Windows Phone, there were a bunch of developers who said, hey, we want to keep building this. They have sort of their own unique gesture-based UI where you can swipe different patterns to perform different functions on the device rather than going through like a series of menus and tapping on a bunch of buttons. It's written in this QML or Qt framework that they developed, which you can also build Android apps using it. I wouldn't say I recommend it, but it's possible. And then, so this is another example of one out there that is not compatible with Google Play Services or the Google Suite of apps, and they're kind of moving in a different, more independent, open direction. Which then brings us to Google Play Services. And so, I chose to include this as a fork of Android, even though technically it's not a fork. This is an additional suite of services that run on top of the Android platform. But as an application developer, in many ways, this is how it functions for us, in that applications built to integrate with this version of Android can't necessarily run on the other versions of Android that are out there. And so this was originally announced at Google I/O in 2012, and it's a suite of proprietary Google APIs that you then access through a client library that you include in your application. And so probably a lot of you are familiar with how this works by now, but just as a recap, so the Play Store, the Play Services actually gets installed directly from the store as its own APK on the device. And then in your application, you include the client library, which then lets you interface with that at runtime on the device. And so what do you get for doing all that? Well, you actually get a whole hell of a lot. You get Google Analytics, push notifications, single sign-on, location services, and activity recognition, maps, billing, ads, Android Pay, and a whole lot more. It seems like new things are going into Google services all the time, Google Play Services. And so how does Google Play Services get onto a device or a specific version of Android? Well, if you're building your own version of Android, first you have to pass what's called the Compatibility Test Suite. And so what this is, it's a suite of automated tests that run against your flavor of Android that then determines your compatibility. And so the requirements range from technical to also stylistic. And so a technical requirement might be, for example, when you try to install an application from the Play Store, it doesn't crash your OS. It's kind of important, right? But then there's also stylistic requirements. So like, for example, if you remember on some early versions of Android, the search bar at the top, the Google search bar, was actually worked like any other widget, where you could drag it and move it around. You could put it down here, like right below your at the bottom of your home screen, or you could remove it entirely. Well, that's not the case anymore. So one of the stylistic requirements of the Compatibility Test Suite is that the Google search bar is always top center on every home screen if your device is going to be compatible with Google mobile services. Okay, so looking at Play Services kind of holistically here, there are some real distinct advantages that you get from opting into that environment and using these in your application. One is you get powerful features, you get the latest and greatest APIs, and then you also, one of the big selling points of Play Services is that it gets updated independently through the Play Store. So these APIs and these services are not beholden to the carriers and the OEMs actually pushing out over-the-air updates of the latest version of the Android platform, which is obviously, even now, still an issue today. I mean, how many devices are actually running Marshmallow at this time, right? Not that many. Oh, so, and then looking at the other side of the coin, there are also some disadvantages that you get along with opting into this Play Services environment. So as an app developer, you're now interacting with this closed source package software suite. And so this, to me, has like two implications. One is that it stands in stark contrast to the Android platform itself in that when I'm developing an app, if I have a bug, I can't just crack open the code and see what's happening under the covers now. You know, it's a little bit more of a black box. And so it makes it a little more challenging to develop, to build on top of it as an app developer. The other thing is that this has security and privacy implications for you as well as, more importantly, your users. And so given that you're interacting with this black box of software now, you can't really make any guarantees about what and how and why your users' data is being accessed. and what that might be getting used for. So this is another reason that some folks are concerned about building an application that opts into this environment. Another drawback can be that it has a rather large footprint, and so this impacts both your overall APK size as well as your method count. So for the DEX method limit. Now these things are less of an issue now because they've actually done a great job of breaking apart Play services. You can include just pieces of it. You don't have to include the whole thing anymore, as well as with things like multi-DEX, which works great on later versions of Android and somewhat on the backwards compatible versions. So we have options now to help deal with this. And then the last thing is that, and probably the most important one for me, is that right away, this Play services is not available on all the versions of Android that we recently talked about, so you're limiting where your application can run. Okay. So next I want to talk real quick about some of the different app stores that are out there. So obviously the most popular one by far is Google Play, at least in the areas where it's available, so outside of China and in some parts of India. And then you have a variety of other app stores, some of them coming directly from the folks who are building their own version of Android. For example, Amazon and Xiaomi and Silent Circle, they all have their own app store. Then you have some other more independent ones. And then I included here F-Droid, which I think is kind of an interesting one if you're interested in Android open source. They actually, so all the applications available in F-Droid are built from source. So they have like this DSL, kind of like if you use Travis or Circle CI to build your application, and you submit the build properties to them, the build configuration, then they actually build your app from source. That's how they ensure that they're not putting any closed source dependencies into their store. And then of course, on Android, you can offer a direct download to your users where they can just sideload the app. And so that brings us to the dreaded F word. We've been dealing with fragmentation on Android for a long time, right? Basically since the beginning. And so what I'm going to propose today is that now we actually have a new kind of fragmentation emerging as Android developers that we have to deal with, in addition to the old sort of fragmentation that we've been dealing with for a long time. And so what do I mean by the old fragmentation? Well, the old fragmentation had to do with things like screen size and display density and different versions of the platform rolling out to devices. And so I'm not saying that old fragmentation doesn't exist anymore. Actually, it's very much still relevant, although we do have some more tools to help us deal with it, things like the support library. And just that the framework itself is now built with tablets in mind, which in the beginning it wasn't. Like if you build an app for the first Samsung Galaxy Tab that was still running Gingerbread, that was a very interesting experience. So now we have tools to deal to a certain degree with the old version of fragmentation. But now this new kind of fragmentation that's emerging, which is forked versions of the operating system, proprietary services and APIs, and also independent app stores, is a whole other world of fragmentation that we have to deal with as developers. Well, fortunately, there are some strategies, there are some techniques that we can use to help us build an app that's going to run on different versions of Android and can be deployed to different app stores without driving ourselves completely insane. And so the three techniques I want to talk about here briefly is going to be number one, introducing alternate dependencies into your app. Number two, using product flavors to build different versions of your application. And then number three is this idea of extracting out a core library project that then is shared across multiple apps. Now, these development strategies are actually useful in more situations than just dealing with different forks of Android and different app stores. And so these techniques might be applicable, say for example, if you're building a free and a paid version of your app, or maybe you're building a Lite and a Pro or whatever. So there are other applications for these things as well. So the first one, alternate dependencies. So what do I mean by this? This is really the most straightforward of all the techniques, which is simply swapping out one of your dependencies that only works in a limited version of or a limited subset of Android devices, and replacing it with one that can work anywhere. So here, essentially, we're replacing environment-specific dependencies with either an open source alternative or even a third-party alternative that's bundled into your application. And so what you're really doing is the only thing you're depending to be there when your app is installed on the device is the Android framework itself. You're not dependent on any other additional services. And so what does this look like? Well, for example, say we're building an application that has maps in it, has analytics, and then also has location services. So you could go the straight Google Play Services route here and use Google Maps and Google Analytics and the Fuse location provider. Or you could swap those out for some other alternatives. For example, in mapping, you could use something like Mapbox or Tangram. For analytics, you could use an open source project like Countly or Adjust. And then finally, for location services, you could use a project that I work on at MapZen called Lost. That actually stands for Location Open Source Tracker. Or there's another framework out there called MicroG that has a much broader scope than Lost, which is actually trying to replace a number of the different components inside of Play Services, whereas Lost is more focused on just the location services. And so what this looks like in your code is you can simply, in your build.gradle file, swap out the dependency that only runs on some devices and include one that will run anywhere. Now, this is not the full story because there's likely going to be some API changes as well, so you're going to have to adjust your code to interact with the new service. But depending on what package you're dealing with, the API may or may not be somewhat similar to the one you're already using. Okay, so the second technique is actually going to be leveraging the Gradle build system and the ability to use different product flavors to use a single project to build multiple versions of your app. And so what do we have here? We have a unique build type for each environment that you want to target. And then in your code, you actually create a common interface that gets used for all versions of your app. But then you can selectively include dependencies and also selectively include classes in your application, in your code base, depending on which environment you're targeting for that specific build. And so really what this boils down to is you have one project that then produces multiple different APKs. And so how do we do this? Inside of the Gradle build system, we're going to be using the build types that are available to us from the Android Gradle plugin. And we're going to declare two different product flavors. So say you have a mapping app and you want to build one version of it using Google Maps, and then you want to build another version of it to use Tangram maps that maybe you're going to launch in China. And so what we can do is once we declare these two different flavors of our application, then we can selectively include dependencies further down the bottom that will only get included for that specific version. So when you build the Google flavor, you're going to include Play Services Maps package, and then when you build the Tangram flavor, you're going to include that package. Then on the code side, to make this easiest to manage, one way you can do it is you're also going to get flavor-specific source folders inside of your project. And so you can see here in our main source folder, we're going to include this interface for a map that simply includes some generic methods about, hey, build a map and show my current location on that map. Then what you have is in your flavor-specific source folders, you're going to have two different versions of your implementation file. Your map impl, you'll have one version that relies on maybe a map fragment from Google Play Services or a map view maybe, and then you have another implementation called the exact same thing that relies on the Tangram package, and that's where you put your environment-specific details. And then when you build your project using Gradle, it's going to selectively include which version of map impl depending on which APK you're building at that moment. Okay, and then so the third strategy here is the idea of pulling out a core library module that then you use across multiple projects. And so this is kind of the inverse of the technique that we just discussed, where with the flavors you have a single code base, one project that produces multiple APKs. With this technique, what you have is multiple different projects that produce one APK each. But the way that we keep that manageable is we take all of your platform agnostic code, your version non-specific code, and we pull that out into a library project that then each one of those applications includes. And so this is what it might look like in your Gradle file with this scenario. So you have your library project that maybe you include as you could deploy it to an internal Sonatype repository server, that then you could include it in different applications that are downloaded at build time. You could include it as a Git submodule. I don't recommend that, but it's a possibility. But really, the nice thing is here is if you build and deploy your library internally, or if it's open source, you could put it on Maven Central and allow others to use it as well, is then you just include it like any other dependency in your application. Okay, so I did build a sample app, which I'm not going to go through here today specifically due to time, but if you go to the link there on my GitHub page, I actually have a little example application that employs some of these techniques so that you can try them out and see exactly how they work in like a very limited, isolated proof of concept kind of way. There is another app that I want to talk about today as well. And this is actually a project that we've been working on at MapZen for a while now. And the reason I wanted to throw this in here is because this is kind of a working example of an application built using these strategies that can run on any version of Android. So what is Eraser Map? It's a privacy-focused mapping application. And really what it is it's an entirely open source stack, both on the client side and on the back-end servers, that relies on open public data sets in order to provide features that you've come to expect from a mapping application, like rendering, search, and turn-by-turn navigation. And so for us, this really serves as kind of our working example of what you can do with an open source, and it includes a lot of mapping-related components, but really this concept applies to all types of applications of what you can build with an open source stack if you want to build an app that can run the same application on all versions of Android. And so that's kind of how we have approached this project. We're actually right now in the process of rolling out our beta. And so if you're interested in this, you can go to erasermap.com and sign up for the beta. Or the source code itself for the Android app is available on GitHub, so you can check that out as well. One other small side note is that the majority of the app is also written in Kotlin. So if you're interested in that, that's another reason to check it out. Okay, so I know in the title of this talk I promised something about the future of Android. And so you all probably have wild expectations that I'm about to tell you, predict the future and give you all like some wisdom of how you should move forward. But I'm actually not going to try to do that today. So I'm sorry if I'm letting you down. What I'm going to do instead is talk a little bit about kind of the things that I'm going to be paying attention to as Android moves forward, and pose a few questions that if you're interested in this kind of perspective on Android development, you might want to be paying attention to. This is an interesting article that I came across as I was doing research for this talk, which declares, and so you might not be able to see the fine print, but this was written in 2011, and it declares that Android will be on almost half of smartphones by 2016. Well, here we are in 2016, and we see that Android was already running on 80% of smartphones 2 years ago. So this is kind of just a good example of how it's hard to predict trends in technology, and so any claims that I would make today would probably be just about as inaccurate as this one. But anyway, so instead of telling you the future of Android, this is what it's going to be, instead I'm going to tell you the future of Android as what might be. And so the first one is, will Android remain the dominant smartphone platform? So obviously we've established that it is today, but maybe the next best thing is being developed right now, and we don't even know what it is. And 5 years from now, we're not going to be at Droidcon San Francisco, we're going to be at, I don't know, Super MobileCon San Francisco with their operating system that has become the dominant player. Will Android open source project forks continue to grow in popularity? Based on the data that we've seen, the trend is moving in that direction. Is it going to continue? I don't know. But based on the number of players out there, like Cyanogen, for example, who are trying to move in this direction, it's worth paying attention to see what happens. This one is kind of a stretch, but will Google remain the dominant force behind Android? Or will some other player, some other version, start to take away some of that influence and push Android in another direction? I mean, this is the exciting thing about an open source platform, getting to see this play out, and I think this is what enables the best innovation to happen. And then finally, for us as application developers, will it become easier or more difficult to build apps that are going to run on all the different versions of Android out there? For our sake, I hope it does, but it's going to take, well, there's a variety of factors in play here, so you really can't say which direction it's going to go because money talks, right? So, you know, for me, I think that most of the innovation that comes from open projects comes from the differing ideas that compete against each other. And I'm not against making money, don't get me wrong. I mean, using, and even using like an open source project to build a commercially viable platform is a great thing. What I don't like, however, is that moves that are made to stifle innovation in the sake of profit. And so I hope to see less of that in Android as we move forward and more of getting back to the roots of what brought me to this platform in the first place. So, thank you so much for coming out today. I hope you got something useful out of the session. I'm not going to take questions here right now because, well, we're coming up on lunchtime and I'm sure you all look as hungry as I feel right now. So if you do have any questions or if you'd like a demo of Eraser Map, come track me down later, I'll be around, and we can chat then. So, thank you.